Hi, my name is Matt Maxwell and I'm the product manager for the Tektronix real-time signal analyzers, and today we'll look briefly at radar and pulse measurements done on the RSA5126A. The RSA is a useful tool because it contains capabilities for spectrum analysis, for pulse signal analysis, and then additional real-time capabilities for troubleshooting. And we'll take a quick look at those three capabilities. Now we're looking at the basic spectrum analyzer display on the RSA5126A, where I have a peak trace and a regular trace, a normal trace. I can clear this and start over again. What I have here is basically a pulsed signal, like a radar signal. It's a chirped linear FM signal, in fact. And over time, you can see I can start to capture the pulse envelope of this chirp, of this linear FM chirp. So now I can add a few more displays to characterize the pulse. This is all included in the RSA's pulse measurement software, where I've got a series of different measurements. I have up to 27 different vector and scalar measurements shown in a table, which can be exported for further analysis offline or for documentation if so desired. Measurements like pulse width, rise time, fall time, repetition interval, as well as vector measurements like frequency difference and frequency error that I can use to characterize the pulse over time. Now, for any one of these measurements, if I stop the instrument here and I want to look at the droop, for example, the droop measurement, I can see what the droop is, and indexed by the pulse number, I can scroll through the pulse statistics showing the pulse trains over time, and it updates for each pulse number. And of course, this works for other measurements, any of the other measurements as well. And in this case, the phase error, this is the difference of the phase from the perfect parabola shown here. Similarly, the frequency difference can be shown, the deviation is shown here, and the difference can also be shown from that perfect expected linear FM chirp, because I told the instrument I was looking at a linear FM chirp. So here I have basically one button measurements to set up and characterize many pulse parameters to quickly figure out if the system is working as intended. So now we're looking at the DPX display of the same signal within 110 megahertz real-time bandwidth. I've got 292,000 FFTs per second shown with the RSA, put into a bitmap display to show more interesting signals that are happening underneath the primary linear FM chirp pulse. So if a radar receiver were to see some of these other artifacts, that may or may not be a problem. The point is, with the RSA, you can see the presence of these signals. I have other controls here where I can manually, arbitrarily adjust the resolution bandwidth to get further down into the noise at the expense of seeing a lower signal level, because now with a 50 microsecond pulse duration, I'm filtering out the pulse basically with the resolution bandwidth, but you see the update rate remains very, very quickly. Last, if I need to look at a wider bandwidth, if 110 megahertz is not sufficient, I can increase the span to 500 megahertz and step across that bandwidth of 500 megahertz and look for artifacts outside of the 110 megahertz, looking for other potential interferers or other signals of interest depending on the application. So we see that the Tek RSA is a great spectrum analyzer with conventional spectrum analyzer controls. The optional pulse measurement suite gives one-button measurements to show 27 different vector and scalar parameters on up to 10,000 different pulses. Also, the Tek RSA has the industry's most advanced real-time spectrum analyzer features for troubleshooting difficult RF problems. I thank you for your time.